Hey guys, this is Mr. Price, and this is going to be our first set of notes for class. And for today's notes, we're going to be pulling them out of the Core Topics SL1 book here that you all should have. And so what I've done is for each example that I'm going to go through and work, it is something that I've pulled from this book. And so if you're wanting to follow along in the book, I've gone ahead and listed those page numbers next to each example. So if you're wanting to know where I'm getting these things from, just consult the page number. The majority of this year for you all is going to be covering statistics and covering calculus. And we're going to start with the probability and statistics part first. And then the second unit for the year is going to be that calculus aspect of it. So without any further ado, we can go ahead and get started. We're going to be starting out of page 241 in your all's books on the section 10a. We're going to be talking about experimental probability to start. And so a couple of vocabulary words that we need to get out of the way. The number of trials in an experiment is the total number of times that an experiment is repeated. So like if I flipped a coin 10 times, like 10 would be the number of trials. The next vocabulary word here that we have is outcomes, which are just the different results possible for one trial. So like if I flipped a coin, my two possible outcomes that could occur are heads and tails. We have something that's called frequency, which is just the amount of times an outcome is observed. And then we have relative frequency, which differs a little bit from frequency. They're roughly the same thing. Relative frequency is the outcomes expressed as a fraction or percentage as the total number of trials. So frequency answers the question, how many times did something occur? Relative frequency says, well, it occurred this many times out of how many. And so what we're going to do is we're going to look at an example. So if you're not a fan of my beautifully constructed table here, the table I'm going off of here is page 244. So what I would like for you all to do is look at this real quick and just look at the information on it. And we can use tables to display information easily. And then from there, we can calculate probabilities quickly from them. So, for example, one thing that we could do, estimate the probability that a person who visits in June is on a holiday. And so what we need to look at is say, okay, probability that they're visiting in June. So we're going to have to be working with exclusively these people. And then, so the denominator here that we're going to be dealing with, the denominator here is going to be 308,300. And then the amount of people that are in a holiday who are visiting, I believe it's Australia. Let's see. There's a lot of people visiting Australia for a holiday here. So we've got 156,500 people. Now, that fraction is fine. Typically, you can express probabilities in three ways. You can have that fraction. You can get a decimal from it. So in this case, we're going to say 0.50. We'll round that up to 8. So that's approximately 0.508, or if you wanted to make that a percentage, we'd say that's roughly 50.8%. So then we're going to look at more experimental probability. So we're going to still use this table here. So we want to estimate the probability that a person who came during this time period here arrived in May. So out of all of the people who have arrived during this time, so what we have to do first off to get that denominator is we have to figure out, okay, well, the denominator is the total amount that we're going out of. So we're going to have to add those totals at the bottom. So I'm going to add the total for April plus the total for May plus the total for June here. So our denominator here is going to be 890,700. And then the denominator, or the numerator, excuse me. So we're trying to find the probability the person came during this time, arrived in May. So that numerator is going to be just however many people arrived in May. So the total for May. And kind of a simple way to think about this is that we're just using our outcomes over our total. So again, you're free to express that as a fraction, as a decimal point, or as a percentage. For today, I'm going to express most of mine in decimal points. So that's going to be approximately 0.293. And we're going to look at just one more using this chart here. So let's see here. Lars arrived in April, May, or June to visit his brother. Estimate the probability of him arriving in April. So what we have to do here is we have to look explicitly at the number of people who are visiting friends or family at this time. That is one of our categories here. So the visiting friends and family column is right here. And it wanted to know the probability of him arriving in April. So the amount of people that arrived in April right here, that's going to be our numerator. Let's see, we can move that up right there. So that's going to be 77,500. And then the denominator here is, again, we're going to figure out what this total amount of people here who've arrived during this time period. So let's see, 500 plus 52,700 plus 59,900. So out of 190,100. And again, we're just going to divide those two to get our decimal. And I'm just rounding all of these to the third spot. So this one is going to be 0.408, or for those of you who like to express it as a percentage, 40.8%. And so there's a lot of different ways to describe probabilities and to display this data, because data can come in all sorts and all shapes. So one of the more popular ways to display data is to use something that's called a two-way table. So we're moving on to section 1B now, and we're going to be out of, and that's page 245 if you're wanting to follow along in the book as we go over this. So a two-way table is a table that compares two categorical variables. And what I mean by categorical variables are variables that are like what it sounds like, that are categories. You have quantitative variables, which are just variables that are sheer numbers, and then you have categorical, which is just categories. So like, for example, we're going to do example 2 here, which is on page 246 in that red book. We've got this table that illustrates whether a child either liked or disliked an amusement park ride, or whether an adult liked or disliked. So your variables here are either liking something or not liking something, as well as whether someone is a child or an adult. So because they're being split into categories, not into numbers, it's categorical. So With a two-way table, a good practice to get into, you'll have to do this anyways, is typically you just have these columns right here, these rows and these columns. But it'll help you out to make a total. So like if we want to know the total amount of people that liked something here, we just say, okay, well 55 plus 28 is 83. So that's our total for that one. Well, the total for dislike, 17 plus 30 is 47. Let's see here, 28 plus 30 is 58. And then the 17 plus 55 is 72. And then if you combine these right here or these right here, you'll get the total amount of people in general, which I believe is 130 people. And again, a two-way table is just a different way to display information. And so you can use it to calculate different probabilities. So let's find the probability that a randomly selected person who went on the ride A liked the ride. So what we'd have to do is we'd have to say, okay, well, how many people enjoyed going on this ride? How many people liked going on this ride? And we look and we say, okay, well, liked, the total amount of people that liked something is 83 there. And out of those 83 people, let's see, that's not going to circle for me, is it? So out of those 83 people, or that 83 is out of how many total, and it's 130. And so I'm just going to stop putting these into the calculator every time. I think you all know where I'm getting these from. So that's approximately 0.638. Let's see, what is the probability that someone is a child and like the ride? So let's see, is a child, and that should be disliked. I copied that one down wrong, and it is all good. So what we have to look at, we're looking for which of these things are going to satisfy both conditions. Since this is a child and disliked the ride, we're going to have to look for where children and disliked intersect, which is here at 17. So then we'd say, all right, well, that's going to be 17 children who disliked it out of the total, again, is 130. So for the decimal there, we're going to say that's approximately 0.131. And you could also express that as a percentage. And for the last one, we want to find the probability that a randomly selected person who went on the ride is an adult or liked the ride. Is an adult or liked the ride. So we have to account for both of those people. So we're looking here, the amount of adults here, we've got 28 and we've got 30. That right there includes all of the adults. So the numerator here is going to be 28 plus 30. Denominator, we're still going to be working with 130. But we have to ask ourselves, have we included everyone who is an adult or liked the ride with that 28 and 30? And the answer is no, because we still haven't included, well, you can be a child and still have liked the ride. So we need to include that 55 right there. And so if we simplify this ends up adding up to, let's see here, 28 plus 30 plus 55, 113 out of 130, which is approximately 0.869. And so that's a very good example of a two-way table. Now, the last thing that we're going to look at today is we're going to be talking about sample spaces and events. So a lot of this is going to be vocabulary. We will get into making some diagrams here in a second, but just for your all's reference, this is all coming out of 10c in that red book, which is page 247. So some vocabulary, we've got something called a sample space, which is all possible outcomes of an experiment. And we denote the sample space here with the letter U. We've got something called an event, which is just a set of outcomes in a sample space with a particular property. And my understanding is that last year that you all went over set notation. We're going to be describing sample spaces and events using that set notation. And so what that's going to look like is that your sample space is going to be your universal set. So the reason that we're denoting the sample space with U, that U is standing for that universal set right there. The outcomes are going to be your elements of your sample space, so the individual parts of it, and then the events are going to be the subsets, the smaller pieces of that. Now, some more vocabulary that we've got here. We've got things that are called complementary events, and a set of complementary events are two events where only exactly one of them can occur. So an example that I always use is that wherever you're at right now, it is either raining or it is not raining. And one of those statements has to be true. You are hungry or you are not hungry. One of those statements has to be true. So the way we denote that is we say if A is an event, then A prime is the complementary event of A. So anytime you see this notation right here of A prime, we need to interpret that to mean just not A. And so what we're going to do is stop and look at another example. So this is example 3 on page 248 of that red book. And we're going to take a normal 6-sided dice and roll it. And we're going to let A be the event of a prime number being rolled. And so using set notation, we're going to list these outcomes. So the sample space of rolling a dice here, the universal set of rolling a dice is the set of all possible outcomes. So if you roll a 6-sided dice, you could get a 1, you could get a 2, you could get a 3, you could get a 4, a 5, and a 6. And that is your universal set there. And we're going to use this set notation to denote it. So the next thing is A. What is the list of outcomes in A? Well, A is that a prime number is being rolled. So on a dice, when you say, okay, well, what are the possible prime numbers on a dice? And you could get 2, you could get 3, and you could get 5. There's a temptation to say 1, but 1 is not a prime number. And then lastly, the sample space for a prime here, not the sample space, excuse me, the subset of a prime, if we're listing numbers that aren't prime, we're basically just going to list all the numbers that aren't here, because A and A prime should compose the entire sample space here. So we're missing 1, we're missing 4, and we're missing 6. And so those are examples of subsets and the sample space. Now, another way that you can represent that is to draw a Venn diagram to illustrate that sample space. And so if we've got this Venn diagram here where we've got the universal sample space, and then we've got this event A that our specific numbers have to meet, we'd say, okay, well, the sample space, the total possibilities that could happen here, we could get a 1, a 4, and a 6, and those would be in the sample space U here, but they would not match the event of being prime. So then inside of that, that's where our actual prime numbers are going to go. So we'd have 2 and 3 and 5 inside of there. And this illustrates exactly the same thing as what 2 up here illustrated. And then we're going to go over just 2 more ways that you can list possible outcomes using these things. And so the 2 ways that we're going to look at is we're going to look at a 2-dimensional grid. We're basically going to create an axis of outcomes, and we have what's called a tree diagram. So what we're going to do, this is on page 248. We're going from example 4 here. We want to illustrate the possible outcomes when 2 coins are tossed using a 2-dimensional grid and using a tree diagram. So with that, let's see here. With the 2D grid, we've got heads and we've got tails. And we've got heads and we've got tails here. And basically, wherever these lines intersect, this is going to represent an outcome for us. So one example, we could have a point here that would give us heads, heads. We could have a point here that would give us heads, tails. We could plot a point here that would give us tails, tails. And we could plot a point here and that would give us tails, heads. And we should denote that this would be coin 1 and that this would be coin 2, but the order of the coins doesn't really matter. Your outcomes are still going to be the same. Now, a tree diagram is kind of the same way. We say, what are our possibilities for the first flip? And I kind of represent them in different ways. So on flip 1, right here, you can get heads or you can get tails. And that's for coin 1. Now after that initial heads, what can happen? You can get another heads or you could get a tails. Or you can get a tails first and then you can go heads, or you could go tails. And the last, however many outcomes are on this last branch of the tree diagram, or how many outcomes you have. And if you wanted to list those out and kind of follow it here, you could go heads, heads. You could go heads to tails. You could go start with tails and then go to heads, so tails, heads, and then you could go tails, tails. And those right there are your 4 outcomes of your sample space. This right here would be your sample space. This is all of the possible outcomes that could occur. And you'll notice it's the exact same for both. Now, the last thing for today is we're going to look at one more example of a tree diagram, and then we will call it for the notes today. So we're going to use a tree diagram to illustrate possible outcomes of this spinner, and we're going to identify outcomes corresponding to getting blue twice. Now, for those of you all who can't see, this one, my handwriting is very small. This is blue, and this is blue. And I guess we can just go ahead. It says white. We'll go ahead and make it red. Make it stick out a little bit better. Now here, just because there's more blue, like the probability is going to be affected, but just the sample space is not going to be affected. A sample space isn't going to take the probability into account currently. So when we're spinning this spinner, how many times? I don't think you know what, we're gonna spin it 3 times. So on the first spin, you can either get blue or you can get red. Like those are the only 2 events that can occur here. And then from there, so that was spin 1. On spin 2 here, you can go blue or you can go red again. And let's say you got red on the first spin. From there, you could also, on spin 2, still get a blue or a red. For spin 2. And then lastly here, on spin 3, from this blue, we could go blue or we could go red. From this red, we could go blue or red. We could go blue or red. We could go blue or red. And depending on how many outcomes you have, these can start to get a little trickier. And so with the tree diagram, I just like to write out all of the possibilities here. I like to write out the sample space, and then we can identify how many times our event of getting blue twice is going to occur. So we could go B, B, B. We could go blue, 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 blue. We could go blue, blue, red, BBR. We could go blue, red, blue, be right back. We could go blue, red, red. We could go Bert. We could go RBB. We could go RBR. We could go RRB. Or we could go RRR. So from there, we're going to say, okay, how many of these outcomes that we've listed have getting blue twice? So I look, that one doesn't, this one does, this one has 2 B's, this one doesn't, this one does, this one doesn't, this one doesn't, and this one doesn't. So we'd say, okay, from there are 3 outcomes. And so, guys, if you have any questions at all over what we've gone over, you all are welcome to join Zoom during class hours, or if on a Wednesday, or if you want to pop in, if I have Zoom open during lunchtime, you're welcome to ask me questions then. You're also welcome to email me or text me on the number for Google Talk. I forget what it's called, but just let me know. I've got your homework assignment posted on Canvas, and we will talk about what submitting that looks like. But thank you all.